All right, let's jump right in. Today, we're unpacking a really critical warning about the actual foundation of our digital world. We're doing an explainer on an impending stress event that's been forecasted for our open source software dependency chains. Think of this as the hidden plumbing of the internet. It's under incredible pressure right now, and according to the data we're about to look at, it might be heading for a major breaking point very, very soon. So, the source material we're breaking down today is a highly analytical forecast developed by researcher, inventor, and author Kevin L. Brown. He uses a unique framework called triune harmonic dynamics, or THD. Now, this isn't just a wild guess. It's a deeply structured, data-driven look at how software systems build up pressure over time and exactly when they're most likely to snap or force us into a rapid adaptation. Here's how we're going to break this down. 1. The hidden software web. 2. Why the system stresses. 3. The 2026 forecast timeline. 4. Testing the hypothesis. And 5. Preparing for the outcome. Okay, Section 1. The hidden software web. Building with borrowed blocks. The crucial point here really starts with understanding how modern organizations actually build their software today. To really grasp this, I want you to imagine constructing a massive skyscraper. But instead of buying your own steel and pouring your own concrete, you're literally building it out of thousands of random, free bricks you found in alleys left by strangers on the internet. Sounds like a completely crazy way to build a real building, right? Well, that is exactly what an open-source dependency chain is. Modern software just isn't written from scratch anymore. It's assembled from millions of tiny, borrowed pieces. It's incredibly fast, for sure, but it requires massive, almost blind trust. And that brings us to the core mismatch. It's wild when you think about it. We are importing these external building blocks at lightning-fast machine speeds. The automated systems just pull in code instantly. But on the flip side, we're only verifying the safety of those blocks at slow human speeds. It takes real time for people to check if those borrowed bricks are actually safe. And that gap between machine speed and human speed is exactly where all the danger hides. Which leads us to Section 2, why the system stresses, rising pressure on the foundation. This dangerous mismatch builds incredible pressure on the entire system. So the THD methodology actually puts a number on this tension. It scores our current open source system at a structural pressure index of 66 out of 80. In this analytical framework, that is incredibly high. It basically means the tension is so severe that a forced adaptation, or a very visible break in the system, is practically inevitable. The system is just too pressurized to keep functioning like normal. Now, it's really fascinating to see exactly where that pressure is coming from. The biggest threat right now is bad actors purposely pushing infected software packages. Right behind that is the rapid explosion of AI tools suggesting code way faster than humans can actually review it. And finally, you have fragile maintainers, meaning you've got critical global systems relying on overworked teams or sometimes even just one person working for free in their spare time.
Brown points out a repeating pattern here, a concept he calls fractal scare invariance. I know it sounds like a mouthful, but it simply means the exact same problem happens at every single level. From a single developer sitting on a laptop making a mistake by trusting a random piece of code, all the way up to giant global banks and hospitals importing unverified code into their mainframes. This dangerous habit of importing without checking, it's just baked into the entire culture of software.
Moving on to Section 3, the 2026 forecast timeline, when the pressure breaks. Because of all this built-up pressure, our software assembly line is heading straight toward a critical window. The core forecast here is super specific. It states that the open-source software world is going to hit a massive visible stress event somewhere between July and December of 2026. Keep in mind, we aren't talking about a standard phishing attack or a random everyday hack. This is a failure in that trust layer, a major break in how we safely borrow and use all those software building blocks. And the analysis gets even more precise by looking at the industry's natural rhythms to find these specific pulse zones. Think about it. The tech industry has mid-year summer updates, intense fourth-quarter security reviews, and year-end deployment freezes. All those business cycles create extra friction. The forecast pinpoints these exact weeks, especially from late October through December, where the pressure event is most likely to blow. All right, Section 4. Testing the THD hypothesis, rules for scientific validation. A true scientific hypothesis has to have clear conditions for both success and failure, right? We have to know exactly how to test it. So we'll know this forecast is confirmed if, during that second half of 2026,
We see some very specific things go down. This includes massive public disclosures of infected open source packages, hackers actually breaking into automated software assembly lines, or emergency actions from government cyber agencies that force companies to tightly track exactly where their code comes from. If we see rapid, panicked enforcement of code tracking rules in late 2026, boom, the forecast is validated.
But hey, science needs falsification parameters too. What would prove this forecast absolutely wrong? Well, if companies wake up tomorrow, realize the immense danger, and somehow magically fix these issues, hardening their systems before July 2026, that completely disconfirms the timeline. Or if late 2026 just passes quietly with no major incidents, the forecast fails. The THD framework demands that we hold the data accountable. Which brings us to our final section, Section 5, preparing for the outcome, rupture or hardening. Let's look at the actual probabilities here and what it means for your organization right now. So looking at the probability matrix for how this all shakes out, we've got three main paths. The highest probability at 40% is integration or adaptation. That means a severe event happens, scares everyone half to death, and forces the entire industry to rapidly lock down their security. Then there's a 35% chance of ongoing painful pressure with multiple medium-sized incidents. But we cannot ignore the very real 20% threat of a true system rupture, where a massive compromise cascades through widely used packages and takes down critical global infrastructure. So that leaves us with the million-dollar question. Take a hard look at your own systems. Look at the free building blocks your development teams are downloading every single day. Is your organization actually prepared to verify every single borrowed brick in its digital foundation before that 2026 window slams shut? The pressure is absolutely rising, and the timeline is set. The only variable left is how quickly we're willing to adapt. Thanks so much for joining me on this explainer, and definitely stay vigilant out there.